All right, let's start this. Hi, everybody. I am Cory. I'm from the States. Right in the middle of the States is a city called Kansas City, where they have great barbecue, lots of developers, have a big developer conference there, too, called KCDC. I've been going there for years. That was actually where I spoke for the very first time. As a side note, if you've never spoken before, I'd encourage you to consider it. It totally changed my life. It's been a whole lot of fun. What keeps me busy is React. I've been doing React since it was open sourced. You got to go way back in time. React is over 10 years old now, so that's why I titled this Lessons from 10 Years. I've been using it since they announced it. Like immediately I saw it, I was working in Angular and Knockout at the time, and I went, ooh, this is really compelling. And it turned out that was right. Now given, I said the same thing about Silverlight, so I'm not always right, but these things happen. Now, the theme of the beginning of this talk is around the future. And this old idea, I see this all the time, that the future is unevenly distributed. And I feel that all the time. Like, as a person from the States, I come over here and I notice you all have a lot more electric cars than the Midwest, for sure. Like, they're all over. In fact, the last time I was in Copenhagen, I can detect the city feels quieter to me than it did before because there's more electrics. Maybe I'm making it up, but it really, I rode around all last night, like an hour and a half or so, just seeing the city, and it's really fun, and it feels like a glimpse of the future that's coming to the States at some point, is that shifts more. And I bring this up because as a React developer, I get to live in the future, and the reason I get to live in the future is I'm an independent, so I spend my time working with a bunch of different companies, helping them be more effective in React. So I don't have to ask anybody's permission when something new comes out. I just go build something with it, learn it on my own, and then I help other teams adopt it. And then I also suggest things based on all the different companies that I work with. So because of that, what I found is over the last 10 years, what I've done just for a simple idea for data fetching just continues to pivot. And it pivots partially for things that I cannot control. Like if we go back to the beginning, some of you in here may be old enough to remember that when React first came out, you had to use a class, and you put a fetch within component did mount. Anybody do this? Am I the only old? Oh, lots of people did this. Okay, so, geez, well over half the room is well familiar with this. And this worked fine. And in fact, in some ways, it felt pretty darn easy compared to our friend useEffect. So a few years later, hooks come out. And to this day, as somebody who works in React regularly, teaches and helps teams, useEffect is probably the biggest foot gun. There are so many examples of problems with it. And it has become this lightning rod for everybody to dunk on React too, because the useEffect API is unfortunate in various ways. It's powerful, but it's also written in a way that lends itself to overuse. Having to manage this dependency array is annoying. And ultimately, in 2019, when this came out, people looked at it and they felt like generally they weren't so sure about it. Still to this day, a lot of people look at it and go, this might be the worst part of React. That's at least my feeling in many cases. And because of that, pretty quickly, one thing that I wanted to do was not have to start from scratch. I didn't want to have to work with it directly. So a year after it came out, I created a hook, a custom hook, called useFetch. And I imagine a lot of you did something similar. You may have called it something different. Now, I'm going to jump out of here for a second, because what I want to show you is just a little example of what I'm talking about here. So if we go out to my profile, I've got a pinned tweet out here, and this pinned tweet is all about lessons from state, and in particular, I want to show this animation. This is a very satisfying animation. So let me pause this for a second. This was the sort of thing that many people were doing when useEffect first came out. Look at all the boilerplate we had. We had state for holding the data we fetched, state for loading, state for errors. We also had to obviously have the useEffect declared so that we could run this code once. Then inside of here, I chose to use promises here, but I could have used async await, but you've probably hit this before. If I used async await in this example, the moment that I try to decorate the anonymous arrow inside useEffect, I get slapped because React says, actually, that has to be synchronous. So now I've got to declare a function and then invoke it inside. So I'm not even showing that piece of annoyance. But then notice the other things I have to remember. I need to remember to declare my catch. I need to capture that error because another frustrating thing about React is that errors within async code are not caught by error boundaries. And if you didn't know that, don't feel bad, because lots of people may not realize that, but at some point it will bite you if there's an error in your async code. Also, errors within click handlers, within event handlers, are not caught by error boundaries. So it's our job to make sure we throw later in the root by holding that in state. So that's why this error state is necessary here. And then you'll notice also little things like putting the loading false in the finally is another easy thing to forget. Then down below, I need to make sure that I'm displaying my loading indicator, throwing the error in the root so that it will bubble to that error boundary, and then finally, my happy path. Now, the funny thing is, this is not perfect. There are still potential bugs in this implementation. I'm not trying to say that this is ideal, because frankly, it's not, but I did create my own hook that converted this into that. And this before and after is very satisfying. I get to take all of that complexity, and to be fair, this code still exists, but now it exists in a custom hook, and it's genericized a bit, and now I can't screw it up. Now I am basically forced to remember to handle loading state, to handle error state. I've already got my state for the data that I've fetched back, so this was a really nice improvement, and I was pretty happy with this. But again, that was, well, a current year. That was back in 2020. So you fast forward, though, a year later, this wonderful library called React Query comes out. And React Query was basically that useFetch hook that I made, but good, like really good. I mean, mine was okay, it was fine, but React Query added so much that I had not even considered. And one of the reasons I'm still to this day a big fan of React Query. Now, at this moment, in 2025, there are some things that I may prefer to using React Query. But still, if you're here today in 2025, this is still a wonderful option for you. And there's some reasons why. A good abstraction creates a pit of success. A good abstraction does things that I might forget. So let me emphasize some of those things that it does. Often when you get requirements for your project, your PM doesn't think about things like caching. It's sort of a geeky thing, but it is something important. Having caching can improve performance. When you use React Query, it is going to encourage you, in fact, it's going to require you to declare a cache key, so that you can cache your requests. And that means when somebody comes back to my product list page, if they've already been there, it's instant, like absolutely instant. And it's instant because that cache is held in the browser. Other things that you get for free with TanStack Query. I just said TanStack Query instead of React Query, it was later rebranded. Two names, same thing. Other things that you get though, have you ever thought about, I drive through a tunnel. I lose a connection. When I come back out of that tunnel, wouldn't it be nice if the site that I'm looking at would make a request and then show me the latest data? That happens automatically. Wouldn't it be nice if when I went home on Friday and I came back on Monday and I look at this tab that I loaded data in, if behind the scenes it checked for fresh data and just showed me that new data? Again, you get that for free. Now, there's lots of other things you get, like retries, for instance. Wouldn't it be nice if retries happened? Again, you're probably not normally hearing requests for that from some project manager, but it is important, it is useful, it improves the user experience. And all these things are built in to React Query. So I was really excited when it came out. Now, you fast forward 1 year later, I'm still using React Query. But then I started using a particular feature of it, which is use error boundary. And React's had error boundaries for a long time. And I know this talk more broadly is about lessons from 10 years in React. And if there's one lesson that I think is particularly concerning for me, is I audit React code bases all the time. So people show me their code base and then they ask for feedback. And usually that audit contains 10 to 12 pages of suggestions from me. Because I've looked at enough React projects, I can just right away glance in and go, here's a bunch of things I would suggest. And it's not just React I'm looking at. I'm looking at performance and security and so on. So there's a lot to consider. But what concerns me is most React applications that I look at still to this day have basically no error handling. If an error occurs in React and you don't have an error boundary, what is the user experience? Anybody know? Yeah. It is a crash, and when we say a crash, the user experience is a white screen. They see nothing. It's just, I was looking at an app, and now it's disappeared. So it's very important to have an error boundary at the root. That's a given. But the other big opportunity is I very rarely see people putting error boundaries at granular levels. And it's really useful to have an error boundary around every one of your pages. So imagine if one page fails, I would really like to still be able to see the navigation. I'd like to be able to see the footer, maybe see a sidebar with sub-navigation. If I'm looking at a page that has a bunch of widgets, imagine I've got weather, and I've got a to-do app, and I have this other task manager over here. It'd be nice if every one of those had an error boundary around them. Because imagine if the weather fails, I would like to just see a little message that we couldn't fetch the weather, but I can still use the rest of the app. That's great. I mean, I literally did have one of my clients who had a production outage because the weather API that they hit went down, and it was a third party, so they had an outage and they didn't have an error boundary around it, so the whole app just goes white. Not good. So back to this idea. Why do you want to have use error boundary enabled here? And actually, this was renamed fairly recently to throw on error. What happens is, remember how I showed you this a moment ago? I showed you the gymnastics that I had to do to make sure that an error actually ends up bubbling up to an error boundary. We had to set the error state up here at the top. And then down at the bottom of the screen, see how I'm rethrowing that error? I have to rethrow that error because I need to throw it outside of asynchronous code so that an error boundary will actually catch it. Again, it's an unfortunate fact in React. I wish the design weren't this way, but it's something that we have to do. Now, what's great news is, if you are enabling error boundaries, and if you go in, I should say, if you are using TanStack Query today, and you tell it to throw on error, what it will do for you is, well, not surprisingly, throw on error. So I actually have an example here from, here it is. So this is the setting that I'm talking about. Nothing fancy, one little Boolean. I'm telling it that I want it to throw on error if there is an error in a query or an error in a mutation. With that little change, what that means is, in my app right here, this code has error handling. But notice that I'm not doing anything. I can't mess it up. And I am a really big fan of APIs that I can't mess up. That I have to do it right, because that's what the API has me do. See, what's going to happen is, if anything in here happens to fail, my query, my fetch to this URL, if it's not a 200, it will throw on my behalf, and that async problem that I was talking about just goes away. This will bubble up to the nearest error boundary, which, by the way, sits over here in my root. There's my friend, the error boundary. So it'll bubble up to this. So that's a really nice feature. And enabling that, what I want to point out too is, notice how we end up, this is pretty concise. I've specified the URL that I want, and then I'm returning that data. Now, as a side note, I want to point out line 13. Something that has become absolutely key that's not actually on my slides, but I really want to draw attention to is runtime data validation. I am guessing that, okay, I'm going to ask this in a weird way. Who in here is unfortunately still working in JavaScript, not TypeScript? Okay, that is 3 hands. And you all looked sad. No, I'm kidding. You're smiling. What's fascinating to me is we only have to go back 3 or 4 years before it was just low numbers. I mean, we don't have to go back that far. TypeScript is now nearly 100% with my clients. I occasionally come across, I've got one client right now that is transitioning to TypeScript because they have such a huge code base. It's just a big lift to get there. But I say that, remember, quiz for the room. Does TypeScript exist at runtime in the browser? No, it does not. If I want to make sure that some runtime data meets my types, that means TypeScript cannot help me. Think about where we get runtime data from. There's a lot of spots. Well, you're probably thinking, well, the first place I get runtime data is from somebody typing in a form. Yes, that's true. But this is an example of runtime data. Line 13. Can TypeScript protect me from the fact that some JSON API, maybe it's written in C#, Java, Ruby, who cares? The point is, at any given point, it could return different JSON. And my TypeScript types will not be compatible with that JSON I received. So then the question becomes, what should I do about this JSON that comes back here? And you'll notice if I hover over line 12, what is the type of that JSON? It is typed as unknown. I also want to point out the other thing I'm doing here is notice I'm not using fetch. I am using Kai. And I really like Kai because Kai is an alternative. Some of you probably use Axios as well, so fetch or Axios are the most popular ways. Kai is an open source alternative. The difference between Axios and Kai is built as an abstraction over fetch. Axios is an abstraction over XML HTTP request. That distinction is important because it means that Kai is lighter, because fetch is just a lighter abstraction. That's also important because it means Axios is a little more powerful. But in my experience, you rarely need the extra power of XML HTTP request. If you want progress, then yes, you need it, but most people don't need progress. So one of the things I also like about Kai is notice that what it returns as the type is unknown. So now I am forced to type that properly, rather than it being typed as any. That's not great. So unknown is preferable, because with unknown, I'm now forced to narrow, and that's what I'm doing on line 13. What I'm using here is Zod. Now, if you haven't heard of Zod, Zod is an open source library that has a really confusing description. TypeScript first, schema validation with static type inference. What does that mean? Who says that at a party? Jeez, no. What it actually is runtime types. That's it. At runtime, I want to validate my data. So when I get JSON back from some random server from AWS, I want to validate that name is a string, and I want to validate that email is an email, and that the URL truly is a URL. Now, a thing to know about Zod, I'm just curious, how many are using Zod? Okay, this is the most important thing I'm sharing today. Like, Zod will change your life because chances are you have runtime issues, and this catches those and screams loudly. It is wonderful. It really improved my coding style and gave me a lot more confidence that the JSON that I was working with was the JSON we expected. So with Zod, what we do, let's just come over here and we'll look at an example for a second. I'm going to pull this up. So you'll notice that I have this food schema. And my food schema sits over here. So this is for an app that we built in my workshop this week. We did a 2-day workshop on advanced React. And here is a schema that describes my food object. So you'll notice that it is a name that's a string, a price that's a number, a description that's a string, an image that's a string, and tags is an array of strings. And then I've also put in some custom messages here. So what this means is when I get some JSON from an API, I can run it through this schema, and if it doesn't meet my requirements, then it will fail loudly at that point and tell me, you said that name would be a string, and it turns out name isn't even in the JSON. Or you said it'd be a string, it turns out it's a number, those sorts of things. So as developers, one thing that's super helpful is failing fast. And I want to emphasize this because, I recently wrapped up with a client who came to me. They had paid a third party $3 million to build them a React application. They slowly came to realize that the agency that they reached out to did not know React. They were trying to learn it on the fly. And he showed me the code and said, the first thing that I want to know is this salvageable? Because we are okay with throwing it away and starting over if you say that that's where we are. And I looked at it, and the weirdest thing was they were about 80% done with a whole lot of stuff, but they were not 100% done with anything. They went with this sort of scattershot approach where they just said, hey, turn a whole bunch of people loose with no real direction and see how fast you can partially complete things. That's not agile. It may have felt that way, but it really created a mess. So the good news is we did not throw it away. I said, let's go take one of these pages. It's 80% done. Let's get it to 100%, and then let's refactor the mistakes that they made, not the least of which was they were using TypeScript, but they had 1,350 innies in the code base. So the using TypeScript was near zero, actually, because they just used any for every type. That was also something they were clearly learning along the way. But they were told to use TypeScript, so they did. It's very interesting. The good news is, you fast forward, we successfully got the project to production. We didn't throw away their code. We fixed it along the way, and all is well. But the reason I bring them up, this Zod schema up here, we put Zod into production. And when I say into production, we weren't actually in production. We put Zod into the code base, so while we were getting feedback from customers in staging, I got a call and he said, I think we need to remove Zod. And I said, what? I thought everybody was finding it really useful. He said, no, I think we need to remove it because we're getting errors from Zod in production, or I should say in staging. And I paused for a second, and I go, like, you do realize it's telling you you're sick. Like, we could ignore that you have the flu. We could ignore these errors by turning off error monitoring. But when Zod tells you that you got JSON you didn't expect, that means our code over here is not written to work with our APIs. So we need to fix that. And that was a tough thing. Now, the mistake that was actually made in some cases is, and this is really easy, when you are describing runtime data, you may make the mistake of being too strict, and I've seen it many times. So here, I've said that name must be a minimum of 1 character. Maybe in some cases, our database doesn't have any names, they're just empty strings. So this could fail. Maybe I'm being too strict. So it actually is important as you do this, talk to your DBA, or if you can query the database and look at production, be careful about being overly strict, because remember, this will throw an error, and then you get to decide what to do with it. But Zod has been really wonderful, and I've certainly enjoyed using it. Okay, so let's go back over here and talk about fetching, because we're moving through the years here. I talked about use error boundary, and we saw how that was simplifying things. Now let's go to the year 2023, and I started using use suspense query. This is a little more divisive, simply because I'm guessing a bunch of you in here have used Suspense. And when you say you've used Suspense, who's used it for lazy loading pages? Lots of people. That's what I figured. But who has used Suspense for data fetching? Anybody? Not very, 2 people. 2 people. So, and if you're using Suspense for data fetching, are you all working in Next.js? Yes, that's what I figured. Okay. So Suspense for data fetching is stable if you are working in Next.js or any other library that happens to support it at this point, although all the others are actually not 1.0 yet. If you look at alternatives like TanStack Start or React Router support for RSC and so on. But this is something that you've been able to do since 2023, to be able to use Suspense for data fetching, and I just want to show you what it looks like. I've been enjoying it. I think it's been great. If we come over here to main. I thought it was main. Oh, here we go. Come over to root. Notice right here in root, what I've put around outlet is a suspense boundary. And I've said that it should fall back to loading. What this means is if any of the child components that happen to be loading into outlet, in other words, the matching route, it will fall back to say loading ... So what's cool about this is, if I am rendering a page, let's say that I'm rendering this particular page, notice how on line 9 I'm calling use suspense query. What that does is it returns a promise. And since this is going to return a promise, it will fall back to that error boundary. So you'll notice here, do you see any loading code here? I don't have any logic here for displaying a loading indicator, but it's handled, and it's handled in the parent right here on line 21. So now I have this composition style that's allowing me to handle loading. So you notice, though, that once you get to around 2023 here, and by the way, everything that I've shared to this point, anybody in this room can use as long as you're using some fairly recent version of React. You don't even have to be on 19. And it doesn't matter whether you're in a React router or if you're using TanStack Query or if you're using Next.js, you can use all this stuff and enjoy it. So I've deliberately emphasized all this because it's really nice how it's broadly applicable. Okay, so that was 2023. Now here's where we get into the more bleeding edge. Now I say bleeding for a reason. When people say the cutting edge is that because it's painful. And React Server Components are at this really weird spot right now. It's been out for a while, and before that, it's been stable for a while, at least in Next.js, and there are a lot of experimental implementations in a bunch of other frameworks. But what's funny about where we are at the moment is it feels like a lot of people have this love-hate relationship with it, and the hate is winning. How many of you in here have even tried React Server Components? I'm guessing a lot of people haven't even touched it. That's 20% of the room, and we're at a developer conference, so I would expect we're people that are more likely to try this sort of thing. So that's not great, given that this has been an option since 2024. Now, part of the reason that you haven't is because I would guess very few of you in here are working with Next.js. If you were, maybe you'd be more like, who in here is using Next.js? Okay, how about the app router, though? Next.js app router? 4 or 5 hands, not very many. So if you are using Next.js and the app router with React 19, then you can enjoy this. So you can see that there's a lot of things that stack up here. Now, React Server Components have been getting a lot of hate since they came out. And let's just talk politics for a second. A lot of the reason I think may have less to do with the technology and more to do with the optics around the whole darn thing. Y'all know who Vercel is. Vercel came in and said, we want to help steward React. We're going to hire some people from the React team, put them on our payroll, and we're going to help move React forward, which is wonderful that they did that they're helping steward. The concern is some people feel like they did that and it was a bit self-serving because React Server Components are a pretty nice play for a company that's selling you servers, that's selling you hosting, I should say. Now, there is some truth to that, but I also think there's a lot of unfair dunking on them as well for various reasons. And I get it, it's about as political as anything out there. What I want to emphasize, though, is this story, if I come over here, it's a compelling API at its core. So here I have a page that loads to-dos. And I could show you the to-do app, but you all have seen them before. It doesn't matter. It's just the code here that's interesting. So I've got this component, and you'll notice that I have a suspense boundary right here, and then I'm calling fetch to-dos, this separate component down here that actually does the fetch. So here's my loading state, effectively, for when I load to-dos. Now, the thing that's cool is you'll notice that this is an async function. You can't do this on the client, but you can have async functions on the server in React Server Components. So here in Next, this works just fine. And you'll notice I am, again, using Zod right here to make sure that the JSON I get back is what I expect. Then I render to-dos. So that's it at its core. Now, I also have error boundaries, but the error boundaries are implemented via the error file. This is specific to Next.js. But at its core, like this little API right here, I think it's very compelling. Now, it's extra compelling when you start considering this little demo. And again, I'm not going to run the demo because seeing the demo doesn't matter, because all the demo is me showing a date from a server. But I want to emphasize these first two lines up here. I have day.js, and I have this localized format library. Now, those are fairly heavy dependencies. But since I am rendering this via a React server component, those dependencies will never go to the browser. What's going to go to the browser is a string that contains the server's timestamp. That's pretty cool. So anytime that I have big, heavy NPM packages, React server components get very compelling. I'm working with a client right now that is struggling with rendering graphs, and they have a chart that, I kid you not, has 30,000 data points on it. And they are pulling down the JSON for 30,000 data points and then rendering that in the client. And you can imagine how it's not exactly instant. And I look at that and I go, imagine if we could render that on the server, and that giant heavy graph doesn't have to, the graph library doesn't have to come down anymore. All that JSON doesn't have to come down anymore. All that comes down is the resulting image. Think of how much more efficient that is to render on the server. So there are places where this becomes pretty sweet. So I would encourage you, it's worth giving it a look. And I am not someone, I should come over here. I don't want you to read this slide as me saying, I'm saying once I get to 2024, I don't do the previous stuff. I still use React Query to this day, even though React Server components are here. And I also am happy to do what else is new here. Here's where we get to maybe the most exciting thing that I want to talk about, which is sync engines. I did a whole talk on sync engines in Kansas City just last month, and I've spent literally the last few months just diving into this topic. This is really hot, and it's a trade. I can tell you right now that you're probably not going to be able to use this in the next few months at your job. Sync engines are super compelling, but they're also a bit cutting edge. Let me show why I'm excited about them, though. So I have a project over here called Local First. And Local First and sync engines are two sort of related concepts, but the nuance around them, I'm just going to gloss over for now, just for sake of time. Now, what I'm going to do is start up a little project here. And you might not know this about me, but I really like cars. So if I retire one day, I think I'd like to have a little car dealership, and on that dealership, I can use this software. So I'm going to open up two tabs. And this is just a little silly app that I created for managing my fictitious car dealership's inventory. And you guys are looking at slides. Thank you. This was happening to me yesterday, too. I've really got to... Thank you for saying something. It's a lot better than just sitting there silent. Okay, so now we're looking at two windows here. What we have on top is a list of cars, and then on the bottom I can add a new vehicle. Now imagine that this tab on the left is my iPhone, and then imagine this tab on the right is your iPhone. Imagine that we're both at work today. Now I come over here and I've got this 300ZX Turbo. And I just negotiated a deal, and it is sold, so I'm going to click Save. Watch the left browser. I'm going to hit Save. That immediately got marked as sold. That's a sync engine in a nutshell. I mean, it's not real whiz-bang wow, but the core idea is this. What if your React application always showed the latest data from the database the very moment that a SQL commit occurred? Like, that's pretty compelling. And some of you are going to think, well, how big a deal is it? Well, it may not be. If you've got an application where reads are infrequent, who cares? Probably not a big deal. If you've got an application where collaboration doesn't happen, again, okay, not a big deal. But a lot of us are writing apps where you and I might be looking at the same record at any time. One of us might edit it, and I would like to know right away if you did. Now, one very simple way you could get this sort of thing is you could just do polling. You could write a little loop and say, every 5 seconds, I'm going to make an AJAX call and then check for the latest data. But here, what I'm doing is I'm using a sync engine called Convex. And Convex is just one of many. You could go look at Zero. You could look at Jazz. You could look at Electric SQL. There are tons of them. And I chose Convex simply because Convex is actually stable. A lot of the other ones are nearly stable, but not quite. This has been out for a little while. The reason I said a lot of you probably can't use this yet is, so Convex, for instance, they are selling you a hosted database. It is a schemaless, or I should say schema-optional database. And when you fire this up, they're hosting the database, and they are also, what's cool is, writing local. I'm going to do something interesting. I'm going to turn off Wi-Fi. And now I'm going to come over here, and I am going to go ahead and change this sold back to on sale, and I'm going to hit save. Now, I just saved. Notice it says vehicle updated. I'm not even online. But it just said it was saved. It wrote. Now, you'll notice the one on the left is out of sync now because this person over here just saved some data, and they're not even online. Now, cross your fingers. This should work. I'm going to go back on Wi-Fi. Let's watch this left tab here. Now, what should happen after I come back online, and the Wi-Fi may take a moment to do it if I do connect. Oh, wait. I thought I turned it back on. Let's try again. By the way, I hope my battery lasts till the end of the talk. I probably should have plugged in. Why are you turning off again? You know, when I thought about this, I didn't expect that turning on Wi-Fi would be the hard part of my demo, but okay, now you're on Wi-Fi? Right. Okay. So, in theory, there it goes. Okay, so it just took a while to get back on Wi-Fi. So what I want to point out is, the other really cool thing is imagine that you were writing local. If you write your data local, and by local I mean you write to IndexedDB in the browser, or you write to memory, or you write to PostgreSQL, or I should say PGLite you can run in the browser. You can run SQLite via WASM in the browser. Lots of ways to do it, but once you do that, now every time I interact with my application, it can be instantaneous because I'm writing to my local machine. It doesn't matter if that call takes 5 seconds, 10 seconds, whatever. It will eventually resolve. What this is doing here is writing to memory, holding onto it, and then eventually sending it up. And that's why I could even go into Chrome. I could go to the network tab right here. And I've got this set to slow 3G right here. Or, yeah, I've got it set to 3G. And even though I'm now on 3G speed, when I change this and I hit save, it instantly saves because it's writing local. You also saw it instantly sync to the other tab, even though I'm on slow 3G, because it is automatically keeping tabs in sync locally for me, even though those are different browsers. So you look at all this, sync engines, very compelling. Now, I want to show another reason they're compelling, which is it's not just a UX play, as in performance, offline, syncing things together, collaboration, reducing the amount of conflicts that we might have. It's also a DX play. And by DX, I mean developer experience. So here is the code for my app. And what I want to point out here is that's line 20. That's my code for getting vehicles. One line of code. Now, it's not quite fair because what I'm actually hitting is an API that is declared over here in this convex folder. And what you'll notice in this convex folder, there's something very interesting that convex does. They say that folder only runs on the server. So this TypeScript that I'm running here, I don't have to worry about that ever getting to the client, but what I'm effectively creating is an API. So you could think of this like me creating a REST API, and this creates an endpoint for me getting a list. This creates an endpoint for me deleting a vehicle. This creates an endpoint for me adding a vehicle. And you can see it's very little code. What I specify is what arguments can somebody pass in and what are the types of those arguments. And then I specify what should happen inside. So very easy to pick up. And then my actual component code here, ooh, that's nice. And think about what I'm getting for free. I'm getting optimistic UI. It's always fast since I'm writing local. If I go offline for a little while and come back in, it's going to send it later. This is really cool. So I've used a lot of tech, and I haven't been this excited in quite a while, like sync engines. And I want to clarify, I'm not sitting here saying go convex necessarily, although they are stable and nice. There's a bunch of other stuff out there. In particular, I'd like to draw your attention to the Local First podcast. I have really been enjoying this podcast, and it's by Johannes Schickling. So he's been interviewing all sorts of people. Actually, I'll get to be on there soon because he invited me on after seeing my slides from, I did this talk here recently, so I'm super excited to be on there. But the reason that this site is particularly interesting is this landscape tab over here. This will give you a sense of how vast the landscape is in this space. So again, I've spent the last few months digging through all of this. I still haven't tried it all. And this is not an exhaustive list either. But I just want to give you a sense of, my prediction is in the next few years, sync engines are what we're going to be using. So I'm actually more excited about that than I am React Server components. And it's the first thing that I've seen that I actually prefer over using TanStack query. Now, I didn't have this in my slides because, again, this just came up a couple weeks ago of me finally getting to use it enough where I can say I'm excited. TanStack DB is an example of more or less helping you do a sync engine. And the beauty of this is you could use this today. If you have a REST API, if you have a GraphQL API, you could start using TanStack DB now. And that's the same story with TanStack Query. Now, the thing that makes TanStack DB interesting is that you don't have to change your back end. You don't have to change your API. You could have any database that you want. This is actually being written in partnership with Electric SQL. And Electric SQL is this interesting project by the guy that created Gatsby. It's not only by him, but I believe he is one of the core maintainers for it. And he's also been collaborating with TanStack to create this. So this is a sync engine that's also stable that you could also consider, a little lower level and interesting. But TanStack DB, I'll just show you just really briefly, or do I have that pulled up and handy? I'll tell you what I won't, just for the sake of time, because I want to talk about some other things. I know I've talked a whole lot about fetching, but there's a reason that I'm talking about fetching a lot. The reason I've been talking about fetching for most of this talk is the term around this is remote state. When you get data from a server, that's what I mean by remote state. You're calling something remote and you're pulling it in. In my experience, 90-something% of the data in your application is fetched from a server. It is remote state. So if you get this right, most of your application just falls into play. A lot of the problems that people have with React fall away because what you find yourself doing is mostly what you use React for is JSX for creating components. And JSX is wonderful, and the component API is super lean and simple. And the ecosystem of components is giant. See, where we are is, I've just talked about a few different state approaches, but there's over 30. Over 30. So let me just give you a sense of how I think about React state. I think about it in terms of categorization. And I've got a course out on Pluralsight that goes through this in detail. It's like a 5-hour course, so obviously I'm not going to go through all of this, but I just want to draw attention to these 8 categories, and I deliberately have URL at the top for a reason. I have found people often underutilize the URL. It's so easy to miss. And in fact, one of my clients right now, they have around 25 pages in their application, and they only have 3 routes. And the reason that is they have 3 sort of top-level routes, and then they're using state to kind of decide what subroutes to show. That's unfortunate. The URL should reflect the whole thing. I should be able to share that URL with you. So be very careful about underutilizing it. Also, as a React developer, it's easy to forget about web storage. Web storage is great. Local storage is often a useful tool. And local state is a good default. When I say local state, I mean use state. And a little tip on that front is try to keep state as local as you can. When I declare use state, I want to put it in a single component and then pass it down on props for a while, lift it to a parent if I need to share it with two siblings, but avoid moving it way up the tree. The higher you have state, the worse your performance gets and the more that you have to drill props through stuff. So I like to default to local and then only lift when I have to. And that's what I'm getting at with this next point of lifted state. Lift to the nearest parent when you have to. And that's not complicated technically. That is a cut and paste. That's what I'm describing. Derived state is key. And when I say derived state, I have an example of that sitting over here from our workshop this week. And I actually, here's how I thought I did. Where did my derived state go? Well, let's go over here. I have an example in here. Okay, I'll just keep changing projects until I find one where I did. Oh, come on. Really? Okay, well, I'm going to show you derived state anyway. So here, I have new vehicle and set new vehicle. I've got make, model, and year. Sometimes you will see people make the mistake of creating another piece of state that should be derived from existing state. So if I came in here and I said const make with model and set make with model, and now if the make and the model change here, I have to also update this thing because I was trying to just have this separate string that contains just part of the information, maybe with a comma in there, maybe with formatting. Another example would be, imagine I had first name and last name in state. Well, I wouldn't want to have another piece of state called full name. No, I would want to derive full name from first name and last name. It's just concatenating strings. That example sounds silly. It seems obvious when I tell you this, but trust me, when you get big components, it's an easy mistake to make. People don't realize that they could derive the information they need from the state that's already up there. A great example of this is forms. And I wanted to talk a little about forms, so let's go back over to my Twitter if I still have it open. So forms are a place where you can derive state. And my take on forms is that you do not need a form library. You'll hear people use Formic or React Hook Form or TanStack Form. Those are fine. Those are useful. I don't generally use them, though, because I find I've got good patterns, and these are the patterns that I use. Now, you'll notice I derive whether the form is valid. I derive whether there are errors, and I derive whether the form is dirty. So to show an example of this, I have a form. Let's just go to errors right here. No, not this one. Here we go. So I have a form in here. And in here, I get to just figure out whether there are any errors in the form based on this derived state. And let me show where that state is derived. Right here on this line 79, I call this validate function because I don't need state to hold whether there are errors in the form. I just look at the data in the form and I evaluate it. So I say, okay, is the name's length 0? Then I know that there's an error here. If the price is less than 0, I know this is an error. So you look at this line, instead of state, I'm just calculating the errors on each render. That's derived state. Now you might look at this and go, well, isn't that wasteful? Well, yeah, technically, but in actual practical terms, I think the benefits of this outweigh the very minor performance impact here because I don't have particularly complicated validation logic. And if it were, I could always memoize it so it only calculates when necessary. So that's what I mean by deriving state. A couple other types of state. You've got refs. Refs are a way to make a DOM reference, but also hold on to state that does not render. Sometimes I don't actually need to show it on the page, but I want to hold on to it. An example of this is if I want to do undo and redo, I could hold on to the previous state in a ref, because I don't need that to trigger a render, but I do just want to hold on to that info just in case we end up reverting that change later. There's also context built into React. I don't use it as much anymore because I have other things I prefer I'll talk about in a second. And then there's third-party libraries. Again, my favorite for remote state is TanStack Query, but there's others like SWR and Apollo that are also great in that space. So you might wonder, well, why would I use third-party state at all? Well, the reason is there's quite a few limitations if you actually think about state hooks. So here we've got a couple of different built-in state hooks. You also got useRef, you've got useContext. But with useState, I can't protect that state. Anybody can set it to anything that they want. And with useReducer, it has its own trade-offs. It's kind of a clunky DX. People, when they look at the code, sometimes find it confusing. It's also weird to me. Hardly anybody uses useReducer. In fact, who in here uses useReducer? 2 hands. See? It's strange to me. It's useful. useReducer is quite useful. You can unit test your changes in isolation, but for whatever reason, it just hasn't caught on. useRef doesn't render, and useContext is for data that changes infrequently. And I'm really emphasizing the infrequently part here, because if the data changes frequently and you put it into context, you tend to experience performance problems. Especially if we're talking about a context that is wrapped around your entire application rather than a subtree. So with these limitations, it leads to me considering third-party options for these. I also don't have granular render optimizations with useContext. And all of these are also only accessible in React. If I want some kind of data accessed outside of React, which has come up for me before, like I've wanted some data before React is even rendering on the screen and I want to hold on to it, well, in that case, I can't use these hooks because they only exist in React. So it might be that I want to do this for performance, like render optimization, or I want access outside React, I want to protect that state, or I just want a DX win like less code or devtools. All these are wins when you talk about considering third-party state. And it tends to be helpful when you want to use the same data or actions in a lot of different spots, when you've got a lot of fetch calls, or you've got complex forms, those sorts of things. So I want to show you, I'm going to do this quickly, 30 different ways to handle state. Let's start with built into React. Half of you in this room have only used half this list. And that's not necessarily wrong or bad. It's just half of this list is React 19. Who's running 19 right now? Not very many people. It's been out for a while. It's safe to adopt. Doesn't mean that you have to use these things. But a lot of this stuff at the bottom is pretty compelling, worth considering. The web platform has a bunch of options that I've talked about before. Again, those totally apply to React developers. General state, there's a ton of options in here. I'll just go ahead and be opinionated. I used to be a huge fan of Redux. My most popular course on Pluralsight is on Redux, and my recommendation is don't use it. At the time that I authored it, I really liked it, but that was a lot of years ago, and better stuff has come out. I prefer Zustand, which Zustand does most of the same things that Redux does with a simpler API. And there's lots of other options here, but Zustand is probably the one that I would consider if I just wanted a general state manager outside of React. And in particular, I like to use it instead of context. There's some reasons for performance reasons and just API. It's a really compelling option to use instead of context. For remote state, I like TanStack Query, but there are other options up here. I'm not a fan of RTK Query simply because it is tied to Redux, and again, it just feels more complicated than TanStack Query or SWR, so I'm a big fan of TanStack Query for this. You can also use routers for state, although some of you may not have that option if you're not using a modern router that contains loaders, but newer versions of React Router and then TanStack Router have loaders so that you can fire off your fetches earlier and you can use that for state. One last option is form state. Again, you don't need these, but you might like these. I really like TanStack Form and React Hook Form. Both of them are fantastic. You just don't need them. You might find that you do fine without. Usually, I prefer without, but sometimes these are nice. So I want to close out with this, and then I'll go to the summary slide. This is a little flow chart that I tweeted out. And I just wanted to visualize how I pick a state approach. This is at the top for a reason, because people underutilize URLs. I want to start there. Is it shareable via the URL? Then I'm going to use it. If it's not shareable via the URL, I'm going to ask, is it data that's been fetched? And if it's for multiple routes, then I'll use a remote state manager like one of these. If it's for a single route, maybe I'll consider using some router's state manager. If it's not fetched data, I'm next going to ask, is this for many components? And if it is, then okay, I'm going to use some shared state manager, and this list is kind of bananas. Past props, use context, local storage, IndexedDB, Redux, Zustand, MobX, Voltio, XState. Like, wow, that's a lot. Now, in actuality, what I would normally do is pass props. At some point, passing props gets really annoying. When is that point? For me, 5 or 6 levels. I'm okay with passing quite a few layers down. Remember, passing props is just passing arguments. You're passing arguments to functions, so there's nothing wrong with passing it a few layers, but at some point, it gets annoying, it doesn't scale. When it gets annoying, for me, I tend to use Zustand if I'm going to have a global, but you could use context as well. Form state, you could use a form library, but there's nothing wrong with using plain old use state and use reducer, up to you. And then finally, if it's not form state, then, well, you can use one of these just fine. So that is the flow chart in a nutshell. If you want to take a picture, I'll pause for a moment. I saw a few cameras. You don't have to, though. I will share the slides so you can get this that way, too. All right. Okay, very good. If I had more time, I would love to talk about React 19, but I'm going to talk about React 19 this way just to give you a sense of why it's exciting. I actually should have changed this picture. Last night, I was out on a bike ride, and I saw this in Copenhagen, this very situation, where all these people had walked across a corner because they didn't put the pavement where people wanted it. So they just trudged through the grass, and there's a dirt path. That is a cow path of sorts. The same thing has happened with React 19. React 18 and previous versions said React thought that people would use React in a certain way, and then at some point they realized, you know what, we were wrong. We need to add some other primitives to make it easier for people. We're going to pave the cow paths. That's what these hooks are about. They make it easier to do things that people want to do, like run server-side components or handle action state, create APIs, handle form state, or do optimistic UI. These are all great. And it's cool, too, because just coincidentally, if you add it all up, there are 19 changes in React 19. I happened to notice that. I thought that was fun. I also created this React 19 cheat sheet. So if you take a picture of that, then I've just got one sheet that describes it all, and you can get a sense of what you'll get once you move over there. Also, you can get to this once I share the slides at the end. So we are just about at the end, so I'm going to bounce out of here. And also, I've only done 16 of 57 slides. Again, I did a workshop for 2 days, so I knew I wasn't going to cover all of this. But I want to do this, though. I said I was going to be rapid fire. This was rapid fire. These were other things I wanted to talk about. Keep your components small. That's how you make things fast. Start local, then lift your state. Avoid using context all the time. It's often overused. Consider Zustand or Jotai instead. Derive your state on render. You probably don't need a form library. State enums are awesome. I didn't get to show that, but Google state enums, they're cool. Use Zod. I'm glad I got to show you Zod. Is anybody excited about Zod? It's free. Be excited. Yes, it's cool. If you are copying JSX, go create a component. If you're copying logic, go create a hook. Not always, but that's React. If you're creating a reusable component, copy and paste it first, and then you'll figure out whether the API is right. Copy and paste 2 or 3 times. In fact, that's what they did with Stack Overflow. They copied and pasted the code, created server fault, and then they figured out how to make it reusable. So in summary, I showed you 30 state options. Consider modern use effect abstractions like TanStack Query. Remember that most of your state is remote. Know the 8 categories of state that I just showed you. Remember to use the URL. It's often underused. React 19 is quite nice. It paves the cow paths for you. And I showed you sync. Sync is super exciting. You probably don't want to use it yet, but keep an eye on it. I think 2026 is probably going to be the year that it becomes more ubiquitous, but you can use it today. Keep your state as local and as low as you can. Okay, so my slides are available at that bit.ly link right up there, the QR code. I have courses on 2 different platforms now. I've authored about 14 courses at Pluralsight, and I've authored a couple courses at DomeTrain. Nick, who owns DomeTrain, is actually here speaking as well. I am a React consultant. I would love to work with your team. If you guys are working in React, I often do audits and help people improve their code base, help them move faster. I do workshops and training, fly all over the place. Did you learn anything new? Please say yes. I'm hoping. Yeah, good, wonderful. Thank you all for listening. Have a great day.